this video, we are looking at solving percent problems. So we will often talk about percentages of numbers. So we might say 50% of our class has brown hair, right? And if we had 15 people, or let's say 16 people in our class, 50% of 16 would be 8, right? 50% is another way of representing half. And we know half of 16 is 8. So let's look at this first problem here, finding the percent of a number. And this first one says 25% of 40. So the first thing we want to draw our eyes to is the word of. As a reminder, when we see of, that is a clue to us that we should multiply. We want to know 25% of 40, which is 25% times 40. So we can change this of to multiplication. Now we also want to change our 25%. So we can either write it as a fraction or a decimal. Now 25% is an easy one to write as a fraction. We know that that's 1/4. But generally speaking, it's always super easy to turn a percent into a decimal because we're just going to move our decimal point 2 times to the left, which would give us 0.25. So 25% of 40 is the same thing as 0.25 times 40. And now we can do that math. 0 times 5 is 0, 0 times 2 is 0, 0 times 0 is 0, 4 times 5 is 20, 4 times 2 is 8, plus 2 is 10. Now we can add these up, and we have our decimal, 2 from the end, and we would get 10. So 25% of 40 is 10. And that answer makes sense to us because we know that 25% or 1/4 of 40 is 10, right? If I said 25% of our 40 students have brown hair, that would be 10 students. Let's try another one here. 90% of 20. So why don't you go ahead and pause the video and try to solve this one on your own. And then once you've gotten an answer, you can resume the video and double check and follow along with me. All right, so we've got 90% of 20. The first thing we want to do is change this of to multiplication. We want to know 90% of 20. So that's 0.90 or 0.9 multiplied by 20. Again, now we just have to do our multiplication. 0 times 9 is 0, and 0 times 0 is 0. 2 times 9 is 18. 2 times 0 plus 1 is 1. So 90% of 20 would be 18. One more problem. So this one, we can see our percentage is larger than 100%. So we should know right away that our answer is going to be bigger than 12 here because we want a greater portion of this number than 100%, which would be a whole, right? 100% of 12 equals 12. So we're going to find 150% of 12. So again, we're going to change of to multiplication. 150% will become 1.50 or 1.5 because we would move our decimal here. And we're multiplying 1.5 times 12. 2 times 5 is 10. 2 times 1 is 2, plus 1 is 3. 1 times 5 is 5, and 1 times 1 is 1. And we would get 18. So 150% of 12 equals 18. Right? So an example of that might be to say you had $12 and it grew by 150%. So that money grew into more than what you started with, and 150% of 12 would be $18. That would be your new amount. All right, now, another thing that we can do with these types of problems is find the whole. So, for example, 120% of what number is 72? Okay, now this what number is a great use for algebra because that what number can be replaced with a variable. It's something that we don't currently know, right? 120% of some number is equal to 72, and we want to know what that some number is. So we can start again acknowledging that of is going to be multiplication, and we'll replace what number with a variable. So we could use x, we could use n, any letter really. So we're going to start by using x. 120% of x means equals 72. So we'll replace our of with multiplication. 120% becomes 1.2. So we have 1.2 times x, and that equals 72. Now, here's a little trick with algebra. Our goal here is to isolate x. Now, isolate means we want this equation to read x equals and then a number, right? We want to manipulate our equation so that we have x is equal to a number. Now, the beauty with algebra is in acknowledging that anything we do to our equation on both sides, as long as we do the same thing on both sides of the equation, it will not change our end result. So let me show you what I mean. Okay, you guys would all agree that 5 plus 2 equals 7. Now, usually we kind of think of this equal sign as meaning the answer. But really, all it's telling us is that everything over here is equal to or the same as everything over here. Okay, now, if we were to, for example, add 3 to both sides of this equation here, so we add 3 on this side and we add 3 on this side, they would still be equal, right? 5 plus 2 plus 3 would equal 10, and 7 plus 3 would equal 10, and we know that 10 is equal to 10. Similarly, if we were to divide both sides by 2, 10 divided by 2 is 5, and 10 divided by 2 is 5. So with algebra, all we're going to do is make sure we do the same thing to both sides of the equation, and we will still have a true statement. So we can manipulate it so that we get our statement to read as x equals and then a number. So in this case, right now it's telling us 1.2 multiplied by some number equals 72. Now our goal is to do the opposite. We want to undo this multiplication here. So in order to undo that, we're going to do the opposite of multiplication, which is division. So if we divide by 1.2 on both sides, that would leave us with x equals 72 divided by 1.2. So let's look at that. We need to move our decimal once, which would give us 720 divided by 12. And I know that 12 goes into 72 6 times, and 12 goes into 0 times. So x equals 60. This means that 120% of 60 equals 72. And we could go back and check our work by solving. We know now that 120% of 60 equals 72. So that would be 120%, or 1.2, times 60 equals 72. Let's check our work. 0 times 2 is 0, 0 times 1 is 0, 6 times 2 is 12, 6 times 1 plus 1 is 7. We have our decimal place here, and we get 72. So 60 is the correct answer. So let's see for another one. 62% of what number is 31? So again, let's go through and replace some of these things. We know that the of should become multiplication. What number will become our variable? Let's use n this time. And is will become our equal sign. Finally, 62% we will change to a decimal. That'll be 0.62. So we have 0.62 times n equals 31. So again, we'll go ahead and write this out. 0.62 times n equals 31. And again, we want to do the opposite here. We want to undo this multiplication. Okay, now just to reiterate, let me show you what I mean by that. Let's say I have 2 times 5 equals 10, right? Now, if I take 2 times 5 and then I divide that by 2, right, it's going to leave me with just 5, this number here, because 2 times 5 is 10, and 10 divided by 2 is 5. So the same thing is true over here. If I have 0.62 times n, whatever n would be, and I divide it by 0.62, it's going to leave me with just n. Right? Just like we talked about with converting measures, we have a number in our numerator and our denominator that are the same, and they cancel each other out. So we are left with just n equals 31 divided by 0.62, right? So n equals 31 divided by 0.62, so let's solve. We'll need to move our decimal 2 times, which would give us 3,100 in our dividend. Now 62 goes into 310 5 times, and that's equal to 310. And 62 goes into 0 times. So n is equal to 50. So this means that 62% of 50 is 31. And again, we could go check our work on that. 62% of 50 is 31. So 62% becomes 0.62. Of becomes multiplication, is would be the equal sign, and 31. So let's check that 0.62 times 50 equals 31. Zero times 2 is 0, 0 times 6 is 0, 0 times 0 is 0. 5 times 2 is 10. 5 times 6 is 30, plus 1 is 31, and 5 times 0 plus 3 is 3. We have 2 numbers to the right of our decimal point, so we would get 31, which is indeed correct. So that's a look at how we can do some percent problems.